What if everything you know is a lie? Time isn't real. Reality is a simulation, and the universe, just one of many. Buckle up, because once you see it, you can't unsee it. The ekpyrotic universe theory. The ekpyrotic universe theory proposes an alternative to the Big Bang theory, which is widely accepted. It posits that our universe is in fact composed of two universes that collided with one another, rather than having originated from a singularity, as the Big Bang theory predicts. It is believed that this impact caused our universe to reset itself, and that following that point, it began to grow in a manner similar to that of the Big Bang. Nevertheless, the theory proposes that the universe will eventually start to constrict at some point in the future, rather than continuing to expand forever. This would inevitably result in what some astrophysicists have dubbed the Big Crunch. Following that, the considerable amount of speed and energy that is involved in the Big Crunch then goes on to cause another enormous collision, which in turn leads to the universe being reset once again so that the cycle can continue to repeat itself for all of eternity. Brane world, the fact that the cosmos is three-dimensional and that you can move in three perpendicular directions is something we take for granted. However, some theories propose an additional spatial dimension in a different perpendicular direction that is not directly perceptible to us. Our universe is a three-dimensional membrane, or brane, that floats inside this higher dimensional realm, which is known as the bulk. Despite its complexity, the brane world image resolves a number of physics issues. Theoretical physicists Lisa Randall of Harvard University and Raman Sundram of the University of Maryland, for instance, put up a brane world theory that suggests the existence of branes parallel to our own in order to explain an asymmetry in subatomic forces. A theory must, however, produce novel hypotheses that can be put to the test through experimentation. Simply explaining known facts is insufficient. Such tests might measure the gravitational waves that black holes release that connect one brane to another in the Randall-Sundram model. The existence of white holes. Everyone is aware of black holes and how everything, including light, is drawn in by their tremendous gravity. However, what about white holes? They are theoretically the exact opposite of a black hole in that they spit out stuff rather than pull it in. It is uncertain if a white hole would behave like the tail end of a black hole, a wormhole, or something else entirely because scientists have never seen one, perhaps because they would only occur in really speculative scenarios. Matter that was sucked into a black hole and ejected by a white hole would need to somehow be preserved and avoid merging with the singularity. Since all of the black holes we have seen have an event horizon that keeps us from seeing them up close, we currently don't fully know what happens to stuff that gets dragged into one. We can only determine the positions of black holes in our universe by observing the gravitational pull they have on nearby things. The big splat. Galaxies will someday drift so far apart in the distant future that light from one will never reach the other. The truth is that when stars age and die, eventually there won't be any more light or heat. The cosmos will be a pitch black, icy, and empty space. According to one hypothesis, it's actually the start of the next universe in an endlessly recurring cycle, even if it sounds like the end of everything. Recall the theory of the brane world. This is the result of a collision between two cold, empty branes, which is inevitable if enough time passes. According to cosmologists Paul Steinhardt and Neil Turok, such a collision would provide enough energy to build an entirely new universe. They refer to this as the ekpyrotic theory, although scientist Michio Kaku has more evocatively called it the big splat. The simulation theory. According to this hypothesis, it's possible that we are all living in a computer simulation that was made by an extraterrestrial culture in a far-off galaxy. Prominent physicists and scientists not only believe the simulation theory is feasible, but are also doing studies to support it, despite the fact that it might seem like a fantasy created by someone who has seen too many science fiction films. Specifically, a group of physicists from Germany are attempting to develop their own computerized model of the cosmos. Unexpectedly, theoretical physicist S. James Gates' new string theory discovery supports this notion even more. In essence, Gates discovered computer code hidden deep within the equations that describe the universe. Furthermore, it's a very uncommon self-dual linear binary error-correcting block code, so it's not just any code. Therefore, it would appear that the quantum core of our cosmos contains error-correcting 1s and 0s. Neo, wake up, the Matrix has you. Plasma-filled cosmos. Many scientists still favor the Big Bang theory, which is backed by two important observations: the cosmic microwave background, CMB, and the universe's expansion. The cosmos was hotter and considerably smaller right after the Big Bang, and it was full with luminous plasma that resembled the sun. The end of this extremely hot phase is still visible to us as a sea of radiation engulfing space. Radio telescopes may still detect the radiation, which has been cooled to minus 454 degrees Fahrenheit, minus 270 degrees Celsius, by the universe's expansion during the intervening billions of years. If the universe has always grown at its current rate, the CMB seems almost the same in all directions, which is inexplicable. Many scientists think that a fraction of a second after the Big Bang, it experienced a brief period of extraordinarily rapid inflation that caused it to abruptly expand from a subatomic scale to many light years in size. The universe is a hologram. Rather than an elaborate computer simulation, this theory suggests that the universe we see is nothing more than a hologram generated by the universe itself. The idea is that when we look up at the night sky, the distant stars and galaxies we see are really more like an image projected on a wall. This holographic principle could provide the explanation as to why the universe appears flimsy when broken down to the most basic of energy scales. Keep in mind that a holographic image is produced when you cover an object with the light from a laser, and then a second laser jumps off the reflective surface of the first later. Another light source then illuminates the image to produce the holograph. It's thought that if variations in gravitational waves are caused by different patterns of light, then it would simulate this holographic image creation process. And if this theory is ever proven correct, it would mean we need to alter a lot of our perceptions of what we think we know about the universe. The multiverse, according to the standard Big Bang theory, an early surge of extremely rapid expansion known as inflation, must be hypothesized in order to account for the uniformity of the CMB. Some physicists believe that our universe was only a single tiny bubble in a huge sea of swelling space when it emerged from this inflationary period. According to Paul Steinhardt's hypothesis, known as eternal inflation, further bubble universes are continuously forming in different regions of the inflationary sea, with the entire ensemble forming a multiverse. Since there is no reason why other universes should follow the same laws of physics as our own, some may have a different speed of light or a higher gravity. The hypothesis becomes even more bizarre. One of the other worlds might theoretically crash with ours. Even though we are unable to view them firsthand, researchers have even proposed that the cold spot in the CMB is the result of one of these collisions. New universes can be created by black holes. Black holes are frequently regarded as the universe's dark reapers, which is not surprising given their enigmatic nature and menacing ability to consume light. However, according to this idea, our universe may have been created by a black hole. According to the theory, matter is compressed by the extreme gravity of a black hole until it reaches a single point so dense that it is expelled, creating a completely new universe out of the same substance. Therefore, a universe with a large number of black holes would effectively serve as a nursery for future universes. Because black holes are invisible due to their event horizon, it is extremely difficult to determine their precise locations in our universe. However, some astronomers believe that this could be because we are simply the offspring of another universe's black hole, which is consistent with theories that suggest we live in a multiverse. We misunderstood gravity. Incorrect understanding of gravity, the sole factor in physics that impacts matter on very vast sizes, is essential to theories of the universe. However, some astronomical observations cannot be explained by gravity alone. If the gravitational attraction of the visible galaxy is the sole thing keeping stars on the fringes of a galaxy from staying in orbit, then their speed is too high. In the same way, groups of galaxies seem to be kept together by a force greater than the gravity of visible matter. There are two potential answers. The conventional theory, supported by the majority of physicists, holds that the absence of gravity in the universe is caused by invisible dark matter. The unconventional option is that modified Newtonian dynamics, a MOND, which was put forth by researchers in the journal Annual Review of Astronomy and Astrophysics in 2002, should take the place of our current theory of gravity. Although they have not yet been established, MOND and dark matter are both equally consistent with observations. There must be more experiments. The universe's heat death. The second rule of thermodynamics is the foundation for this hypothesis, which posits that if the cosmos were to be infinite, it would also have to be indefinitely ancient, In other words, if a star is observed to be 1 million light years away, it would only be possible for it to exist there if the universe were at least 1 million years old, assuming that the speed of light remains constant. Consequently, in a universe that is endlessly ancient, the phenomenon of heat death implies that, in the end, the entirety of the universe will reach a point at which it will have the same temperature throughout. Once this happens, the cosmos will cease to change. Nevertheless, the notion that the cosmos has always expanded at the same rate would have to be true in order for this theory to be valid. There is one aspect that would be in direct contrast with other concepts, such as the theory of cosmic inflation. Space-time superfluid. Even if space only has 3 dimensions, there's still a 4th dimension in the form of time, so we can visualize the universe existing in 4-dimensional space-time. According to some theories, like one proposed by Stefano Liberati of the International School for Advanced Studies and Luca Massioni of Ludwig Maximilian University in the Physics Review Letters journal, this isn't just an abstract frame of reference containing physical objects like stars and galaxies, but a physical substance in itself, analogous to an ocean of water. Just as water is made up of countless molecules, space-time, according to this theory, is made up of microscopic particles on a deeper level of reality than our instruments can reach. The theory visualizes space-time as a superfluid having 0 viscosity. An odd property of such fluids is that they can't be made to rotate in a wholesale fashion, like an ordinary liquid does when you stir it. They break up into tiny vortices, which in the case of superfluid space-time may be the seeds from which galaxies form. Dark energy observation is deadly. Every time we look at dark energy, we're murdering the cosmos, according to theoretical physicist Lawrence Krauss. Astrophysicists estimate that dark energy accounts for 70% of the universe's total energy and is responsible for many of the mysterious anomalies we observe in deep space. According to Krauss, our universe was created as a result of the transition from a false vacuum to an ordinary vacuum, which occurred when some unusually high energy with gravity-repellent qualities decayed into 0 energy. According to the quantum Zeno effect, which is a concept in quantum physics, an unstable item will never decay if it is regularly observed. By driving the cosmos back to its previous condition when it was a false vacuum, Krauss argues that if dark energy is continuously detected, we are maintaining its instability and shortening its duration. However, you can bet your bottom dollar that astronomers and physicists will continue to research dark energy for some time to come, because it provides the answer to many of the riddles in our universe. Hopefully, such consequences won't be noticeable. The Panspermia theory, the Greek word panspermia, literally means seeds everywhere. According to the panspermia idea, the seeds of life are found all across the universe and can naturally spread across interstellar or even intergalactic space. The idea that life on Earth might have started from seeds brought to our planet by meteorites and comets from the furthest reaches of space is even gaining traction among certain people. This notion has gained a lot of support from the recent discovery of a variety of extremophiles, organisms that can survive in harsh circumstances that we previously believed were unsuitable for supporting life here on Earth. We now know that life as we know it can endure in conditions of extreme cold, extreme heat, high radiation levels, and oxygen deprivation. Every possible scenario a creature could encounter when stowing away aboard a meteor or interstellar comet. The singularity, prominent futurist Ray Kurzweil, is adamant that humanity will undergo what he calls a technological singularity in the ensuing decades, during which we will discover how to transcend biology and all of its constraints, including death. According to Kurzweil, truly intelligent civilizations, like mankind in his opinion, are bound to develop into extremely intelligent, perhaps machine-based entities with exponentially increasing computational capacities. The theory goes that when we reach this so-called singularity, our technology will be so sophisticated that we will be creating groundbreaking new discoveries almost every day. By harnessing the power of our own sun, we will be able to achieve incredible intergalactic feats that were previously only imagined in science fiction. Things like teleportation gadgets, Dyson spheres, and cyberminds are not just feasible but almost a given in this society. Of course, there are many others who doubt this notion, such as Noam Chomsky, who thinks it is just the fantasy of science fiction fans. Others only think that before we humans ever achieve the singularity, we will recklessly destroy ourselves. Retroactive precognition, a highly controversial research titled Feeling the Future, Experimental Evidence for Anomalous Retroactive Influences on Cognition and Affect, was released in 2011 by Dr. Daryl J. Bem of Cornell University. According to the report, Bem tried to find precognition, knowledge of future events, through a number of trials, based on his hypothesis that there are anomalous processes of information or energy transfer that are currently unexplained in terms of known physical or biological mechanisms. Bem came to the conclusion that future events could, in fact, have an impact on a person's cognition in the present through the evidence he gathered. Bem assessed the capacity of 1,000 college students to properly infer random information in one study. In another study, participants were given a reverse memory test where they had to classify random phrases that they would then have to memorize. Surprisingly, the test findings indicated that pupils who deliberately worked to memorize terms in the future had a higher chance of remembering them in the present. Shadow matter, multiverse theory. Dark matter may be familiar to you. The vast bulk, more than 80% of the matter in the universe, is made up of dark matter. It is invisible to us, and it appears to interact with the universe's regular matter only through gravity. However, the way its gravity pulls around what we can see lets us know it exists. Astronomers have been speculating about dark matter for decades and have developed a plethora of hypotheses to explain it. According to one theory, at least some dark matter may be shadow or mirror matter. What exactly is mirror matter then? You may be familiar with the concepts of protons, neutrons, and electrons. Protons and neutrons can be decomposed into smaller particles known as up and down quarks, it turns out. The up and down quark, electron, and electron neutrino comprise the initial generation of normal matter. Everything we perceive in the universe is essentially made up of those four fundamental particles. The theory that fooled Einstein, the predictions made by Meckel and Hutton, were predicated on flawed reasoning. However, there are also striking instances of equation-based deceptive evidence. For instance, Einstein is said to have said, "The theory of Bohr must then be right," in response to Niels Bohr's 1913 prediction of the precise frequencies of the particular colors of light absorbed and emitted by ionized helium. Bohr's predictions were accurate to multiple decimal places, which immediately convinced Einstein and many others. However, they emerged from what is now recognized as a seriously faulty model of the atom, in which electrons really circle the atomic nucleus. Bohr was fortunate in that his model had some truth in it, even though it was fundamentally incorrect. This was sufficient for his predictions regarding ionized helium to come true. Electrons as tiny balls, Arnold Sommerfeld's Bohr model development may be the most striking example. Sommerfeld made the electron orbits elliptical and adjusted them to Einstein's relativity theory. All this appeared more realistic than Bohr's simplistic model. We now know electrons don't orbit the nucleus. However, early 20th century scientists saw electrons as tiny balls and imagined their velocity would be similar to that of balls. This was wrong. Current quantum physics shows that electrons are strange and behave in ways that are incomprehensible to humans. Atoms' electrons don't even have a precise position and time. Such factors underlie the famous saying, "If you think you understand quantum mechanics, then you don't." Sommerfeld's theory was based on a major mistake. In 1916, Sommerfeld utilized his model to create an equation that accurately represents hydrogen's light absorption and emission colors. This equation is identical to Paul Dirac's 1928 relativistic quantum mechanics equation, light but make it faster. There's a theory that says the speed of light, which is a universal constant, wasn't always that constant. Current studies of cosmic microwave background (CMB) radiation present a challenge, even while current observations show that the fixed speed of light is 186,000 miles per second, and much of modern physics depends on this precise speed. Light must have permeated every part of the early universe due to its uniformity across distance and space. However, rather than a steady CMB, we should see cooler and denser regions given the size of the universe today and the speed of light. The inflation theory was created to explain this seeming conflict. Before expansion, light was able to reach even distribution since the cosmos was considerably smaller in the remote past. However, this little universe needed special circumstances that are impossible to test or duplicate. An alternative was put out by João Maguajo, who suggested that light may go farther quicker in a universe that was younger and hotter. In our theory, if you go back to the early universe, there's a temperature when everything becomes faster, Afshorty explains. Light travels at an infinite speed and outpaces gravity in its propagation. Similar to how water transforms into steam, it is a phase change. Its back, luminiferous ether, strikes again. Our collection of strange universal hypotheses concludes with the possible resurgence of luminiferous ether. This hypothesis, which formerly maintained that light flowed via an invisible medium called ether, is now among the most well-known failed theories in scientific history. To support their claim that ether exists, Albert Michelson and Edward Morley constructed the interferometer in 1887. However, things didn't work out as expected. Michelson and Morley anticipated that when the apparatus divided a beam of light in half, the two beams would travel distinct courses through the ether and strike their targets at different times. The ether should have produced a delay for the right angle beam, because one was traveling in tandem with the Earth's rotation, while the other was pointed at a right angle. Rather, Michelson and Morley discovered that the beams came simultaneously, regardless of how many times they ran the experiment. This marked the beginning of ether's demise, which was completed by Einstein's work on special relativity in 1905. Ether has returned. According to new scientists, ether has been compared to the effects of dark matter and dark energy by a number of study teams. The exterior and exuberant gravity fields in the Relmond theory above resemble ether as well. It's worth investigating the possibility of an ether renaissance, even though there isn't any concrete evidence to support it. Better yet, it has enormous lyrical potential for a resurgence that few could have foreseen.